Welcome to NASA Edge.
An inside and outside look
at all things NASA.
You okay?
What's up?
Oh, yeah, sorry, I'm just, I need coffee. I went to that Marvel movie marathon where you literally sit in the theater and watch everything.
Oh, leading up to the Avengers.
Yeah,
Edge of Ultron. Oh, cool.
There's like 400 hours of footage and popcorn, and I'm sorry,
Well, we'll get it together because
Yes.
we have a jam-packed show, Franklin. We're going to be talking about Advanced Exploration Systems, or AES.
Yeah, and one of those technologies is 3D printing that is actually up on the International Space Station, Blair.
Yes.
Hey,
Let's pull it together.
later in the show, you're going to be talking with Deanne Bell with the futureengineers.org.
Yes, I am going to be talking to you.
And in the meantime, I had a chance to sit down with Jason Cruson, who is the head of AES, and he's going to tell us all about the cool technologies coming out of his office. Let's check it out. So Jason, I understand that you're the Q of NASA.
Well, that's an interesting reference in itself, but it's a nice analogy. If you think about Q was getting ready for Bond to go off and do whatever mission he was being charged to do. Our group is much like that. We're designing all the systems to send our crews off to explore deep space.
Now, within your portfolio or your technologies, what are you trying to develop?
So, a couple fundamental things. You need to be able to get into space, you need to be able to live in space and be productive when you're there. So we're building a lot of the stuff that allows you to live in space. So we are developing some of the next generation habitation systems. So where's the home? How are people going to live in that? Life support systems for it, how are you going to handle logistics and management of that overall being able to live in space.
Now, I guess, like, let's say when we go to Mars one day, we have the first humans on Mars. The first thing that comes to my mind is going to be spacesuits.
Absolutely. So we're also advancing the new spacesuits technologies. In spacesuits, we see you have what you see on the space station today. They go out, they repair something, they fix something, they come back in. On a trip to, say, Mars, you're going to potentially have to go out, fix things along the way, long duration there. And then when you get to the surface, you want to go outside.
Right. Now, one of the cool labs we have here at NASA Johnson Space Center is the Portable Life Support System Ventilation Laboratory. And that's where they're working on the spacesuits of the next generation.
Correct, yeah. So the suit is made up of two parts, the actual garment that you wear and then the backpack, the portable life support system. The life support system, the one we have, has been very reliable. However, it's getting pretty old at this point. And there's a lot of new technologies that we want to actually incorporate in the backpack of the future. For assembling the space station, or what we did on a shuttle, you're working in zero gravity, in near zero gravity. So the weight of the suit didn't really matter as much, the mass of the suit. But when you get to a surface, even though with the reduced gravity on Mars, you're still going to have to carry around that weight. So you're going to need a lighter weight suit, and also one that you can use more frequently, and also the one that puts up with the environment, the dust, the rocks, and all those kind of things. When we did those short duration EVAs during Apollo, we only did a very few number of them, and we were there on the surface of the moon for a very short time. On Mars, we're going to be there for a long time.
Mobility will probably be an issue. You said weight's an issue.
Yep.
The flexibility of actually working in that environment would be a key factor.
Correct, yeah. So a lot of the station assembly, they optimized the suit to working on the space station. So your work zones and such, you're not picking up things off the ground, you're not using hand tools and those kind of things. Instead, you're turning bolts and all that. So you have a different type of work that you're going to be doing.
Now, is there something with that backpack, is there something that you want to try to miniaturize it, they make it as small as possible? But on the flip side, you want as much oxygen the astronauts to breathe to stay out there for extended periods of time on the surface.
Yeah, so you have this hard challenge of wanting to be out there as long as you can be out there and making it as lightweight as possible, which is what most people can relate to if anybody's ever traveled. You don't want to be carrying around a big heavy bag all the time either. So.
That's right, that's true. Now, what are some other cool technologies going on?
One of the problems we have is managing all the logistics. If you're going to be gone on a trip and you pack your car and you need to figure out where everything is going to be in, say, your motorhome over the course of a couple of years, how are you going to find all that stuff? So what we're going to do is use next generation RFID, or what we call radio frequency ID tags.
Okay.
And what those allow you to do is wirelessly track and inventory where everything is inside of your vehicle.
That actually makes sense because, especially you take a look at something like ISS, where you probably have thousands and thousands of pieces of equipment on the station, and how you keep track of all that.
And on space station, we don't sometimes. There are a number of items that we've lost on the space station, and we have to potentially fly a new one up. On the space station, you have the additive benefit of the crews changing every 6 months. So imagine if you were living in your house for 6 months, you put everything where you wanted it to go. Somebody else comes up 6 months later and moves it all on you. And then you come back again, and nobody knows where everything went.
Right.
So everything will have the equivalent of almost like a high-tech sticker that actually tracks every piece, and you'll have different types of readers. So you have readers that are in between modules, so you can track when something moves from one module to another, and you'll have other readers that may be handheld, so you can scan your storage bags and figure out which bag is it exactly in. We're even looking at how do you make one of those scanners and put it on one of our flying robots.
Like spheres?
On spheres.
Oh, okay. Yeah.
So we're actually going to test a mobile RFID reader where you actually attach it to the robot and let the robot figure out the inventory. It can go out and manage an inventory where everything is. The crew actually doesn't have to do that kind of mundane task. The robot can actually go off and do that. And in fact, our Space Technology Mission Director colleagues are starting the development on that robot that will follow on after Spheres, and its name is Astrobee.
One of the cool technologies that we've been watching closely is the additive manufacturing, our 3D printer. We have one on station now.
Yeah.
How's that coming along?
So we talk about all these parts and pieces that you want, and you try to predict everything that would ever go wrong. Well, we're going to not think of some things. So one of the advantages of additive manufacturing, if we don't have a part, we can just order it up and have folks here on the ground design it digitally,
Right.
email the file up, and then print out the part on orbit.
And how long is that process in terms of making a tool or making a piece of technology?
So on station, we've already printed over 20-some parts. And in fact, you can print several parts per day, whatever you want, just on a single printer.
This is Franklin.
Hey, Franklin, what's the code for Q's lab?
You know, I'm not quite sure, but try this. It usually works for me.
All right.
Up, up,
Not really directions.
down, down,
Got it.
left, right, left,
All
right,
right. Yep.
BA, select, start.
Mission complete.
Chris, that was a great segment. And that piece on RFIDs, I wish I had that technology in my house so I can keep up with my phone and keys.
I like to keep in all the toys that my son has. I mean, he's losing toys all the time.
Yeah, they're under your feet.
That's true. Hey, Blair, you all right?
Blair,
Did he watch the movies last night?
he must have left the theater and came right to the set.
I tell you what, let's continue on. I don't know what his deal is, but another cool piece of technology at the end of Jason's piece was talking about the 3D printer. And you had a chance to sit down with Nikki Werkheiser.
Yeah, Nikki was telling me about the technology that is up on the ISS and how this might be used in the future of space exploration going to Mars.
Hey, let's check it out.
Today we're at the Additive Manufacturing Lab at the Marshall Space Flight Center, and I'm talking with the 3D Printing in Space Project Manager, Nikki Werkheiser. How you doing, Nikki?
Hi, doing well, thanks.
Additive manufacturing, exactly what is it?
So additive manufacturing is actually the kind of formal term for 3D printing. Traditional manufacturing is subtractive. You have a material and you take away from it. Additive is any process really where you actually build the part that you're trying to create layer by layer. So it's additive instead of subtractive.
3D printing has been around for a long, long time. So why is it right now we're talking about doing 3D printing in space?
So 3D printing, you're correct, it's been on the ground for quite some time. But as you probably know, in space travel, we depend on flying every single thing from the ground to the space station, for example, that we might ever need. So our supply chain from the inception of the human space program has really been quite limited. But when we really start to think about exploring further out destinations like Mars or asteroids or the moon, that supply chain model really isn't feasible. We have to think about how we would respond in real time in a sustainable, affordable way if parts get lost or broken. If we're doing science, for example, just like in a lab on the ground, we have disposable hardware, sample containers and syringes, things like that, that right now we're completely dependent upon launching from the ground to space station. So being able to create what you need when you need it on these type of missions is really a critical enabler to sustainable, affordable exploration missions.
Well, I've seen 3D printing work here on the ground, but to get it in space, what are the technology hurdles that you have to get over to make sure it works the same way in space as it does here on Earth?
Right, so those were actually our exact questions. As a matter of fact, it was back in 1999 that Ken Cooper here at Marshall Space Flight Center flew the first 3D printer in on a parabolic flight to see how it would react in microgravity. Since then, the company Made in Space, which we have a Small Business Innovation Research Award with and actually built the 3D printer that we've launched to space station now, has flown over 500 parabolas on those flights through NASA's Flight Opportunity Program. So from that, we've gotten some really good data. We've been able to see in microgravity the basic response when you're laying the layers and performing additive manufacturing. However, you only get the 20 to 30 second spurts of microgravity on those flights. So the bottom line is that the space station is actually the only platform we have in the entire universe where we can test this process out and print a complete part in microgravity. And that's why the first printer that we just launched, it is the first 3D printer ever in space, and we launched it on SpaceX 4 recently. That's why it's called a technology demonstration.
Now on the table right over here, we have a replica of what is flying on the ISS right now. Exactly how does this 3D printer work?
So this first printer that we're flying, we're actually operating in the microgravity science glove box. And that is because since this had never been done in space before, we did not have all of the data for things like flammability and off-gassing of the heated extruded material that we're printing with. Since then, we've collected all that ground data and found that actually the results are promising. The next printer will actually operate outside of MSG. We'll have a next generation that's based off of what we've learned off this printer. We've already learned a great deal. When you're designing something for space flight, you actually need more automation than you have on the ground. Astronaut time is very valuable and limited, so you want to be able to automate. You also want to be able to control it remotely from the ground as much as possible. So you'll note, for example, that we have 2 large windows in the printer, and we'll have cameras aimed at those windows during the printing process. And we will be able to see in detail as the layers are being deposited how that process is unfolding. What's really exciting about this is we can actually email our 3D print files directly to the 3D printer from the ground to space station. So it sounds very kind of science fiction, but it's not. It's going to be science fact very soon.
Tea Earl Grey hot.
What material is being used in the production of the parts that are going to be made on the ISS?
Sure, so for our first printer, the technology demonstration, we're actually using ABS plastic, which is the same plastic. If you see here, this is a little piece of the filament. This is the same plastic that Legos are made out of, for example. The filament that we use is just like this, and to be quite honest, it looks almost just like your weed eater spool. We're actually looking at the next generation printer as well for even more materials, stronger plastics, for example.
We talk about plastics, but when we get down to the point where we're talking about tools that break,
Sure.
What is the future for using metals in space and building those type of tools?
Right, so at NASA we actually have what we call the In-Space Manufacturing Initiative. And that initiative actually is composed of a roadmap or a vision of all the integrated suite of capabilities that we'll really ultimately need for exploration missions that we want to test on space station. We also want to do things, as you mentioned, like printing with metals in space, printing electronics as well. We actually, last year, NASA released a small business and innovation research proposal for a recycler on how to take that 3D printed part and turn it back into usable feedstock.
Nikki, what are the goals of this technology demonstration on the ISS?
So for the technology demonstration, it really has 2 phases. And the very first phase is specifically just to answer the question, does the additive manufacturing or 3D printing process work in microgravity the same way it does on the ground? So for the first phase, we'll actually be printing a lot of parts that may not look super exciting to the layman, but are very exciting to us. We'll have coupons. So we'll have things that look like this. This is a tensile specimen. We'll be doing things like compression and flexure and torque. For those parts, we'll be watching from the ground as the parts are printed through the cameras live. So we'll be able to tell a lot of information and data we'll be able to see immediately. However, to really determine that, we'll be flying those very first parts, those coupons, we'll be flying those back to the ground And we have printed those same parts on the flight unit before we launched it. So we'll be doing some detailed engineering analysis and testing to compare those parts. Once we have established that the 3D printing process does work the same in microgravity as it does on the ground, we have a second phase. And how I like to think of that is the first phase really focuses on the printer and the printing process. In the second phase, we actually turn our attention more to the parts that we're printing. So utilization parts, we have a broad range, and we're developing a utilization catalog. You can have things like sample containers, small hand tools, replacement parts for exercise equipment or medical tools. There's just a plethora of different areas and categories we're looking into. But the thing there is to learn how to design these parts and build them in microgravity and to create kind of a certification process. We've never actually made the parts we needed in space. We've launched everything from the ground, so we have a very well-known process for how we handle things like safety and flight requirements. So it's kind of fun to start thinking how we would certify a part that we actually built on space station. So those are the things we'll be working in the second phase of the technology demonstration. One example, we had a payload on orbit, and you have to change filters out as a requirement every so often, and it was time for the filter exchange. And the filter cap was missing. It's a real simple little part. We were able to 3D print that on the ground in about 45 minutes. Of course, we didn't have the 3D printer on board when this happened, so they actually had to wait 6 months for the next supply ship before they could use that facility. Even though that wasn't a life-threatening example, it's one that has very real and meaningful implications to the science and to the daily operations on space station.
What's going to happen in the next generation of 3D printing in space?
Yeah, so we're already working that, and everything that we learned from this technology demonstration, including what we've already learned from the design and the operations, getting it ready for flight, will feed into the next generation printer. The really exciting thing about the next generation is that it's going to be a commercial printer. It's called the Additive Manufacturing Facility, and it's being developed by the company Made in Space, and they're out in Silicon Valley. So it won't just be NASA or the government that has access to 3D printing parts in space. It will be available for use by industry and academia, small businesses, large businesses that are interested in making something in space. So I think it's very exciting to think about kind of opening that door and opening the door to the space station and able to manufacture parts in space to more people than just directly NASA.
This technology is awesome. And I got to tell you guys, in light of all the technology that we've seen in the show today, I've got something a little special that I've worked up with the help of our good friend Jarvis. We're going to talk to Deanne Bell. Hi, Deanne. Thanks for being on the show.
Okay, well, we're rolling and we're good to go.
Let's get started with a very important foundational question. What exactly is the Future Engineers program?
Right, so Future Engineers is a program that was started to really inspire the next generation of innovators and explorers. It's a website. You go to futureengineers.org, and there's all kinds of education resources. And our website challenges students to create 3D modeled inventions for space. The program is an American Society of Mechanical Engineers Foundation program in technical partnership with NASA, and it's really exciting. Our first challenge launched with the first zero-gravity 3D printer that went to space, and that's not the first and only challenge. We have many more challenges in the pipe, and we're constantly developing new challenges and new curriculum to really connect the excitement of space exploration and space research with the excitement of creating a 3D model and turning your idea into a 3D modeled reality.
Recently, you announced the winner for your first Future Engineers Challenge. What did that first challenge involve?
The first challenge, we challenged students to create a space tool for astronauts. And we had so many different submissions from all corners of the country. And ultimately, we chose 10 semifinalists in each age group. We had 2 age groups, under 13 and over 13, that are enrolled in a K-12 school. And our winner in the juniors age group is named Sydney Vernon, and she designed a space planter to grow a seedling in space. Our winner of our teen division, his name is Robert Hillen, based in Enterprise, Alabama, and he designed something called the MPMT. It's the Multi-Purpose Precision Maintenance Tool. And he basically took like a gajillion different tools and put it all into one to be 3D printed on station. And the excitement is, that one actually is getting 3D printed on station.
What's next for Future Engineers?
There is so much excitement going on with the Future Engineers program. We are growing. We are always in the process of developing new challenges. This program wasn't just one challenge with that first printer that went up. We're really focused on a multi-year endeavor of getting students creating their inventions and 3D modeling them in the computer. Every challenge that Future Engineers issues in partnership with NASA is going to be centered around research that's going on at NASA. So it's a really great opportunity to pair all the excitement in all the different areas of NASA research with K-12 programs to connect it with students in the classrooms.
How can students and future engineers get involved with the Avengers Initiative? Future challenges, it's future challenges. How can they get involved in future challenges?
Right, so you can get involved just by going to futureengineers.org. The site's more than just a place to register and submit a model. There's all kinds of cool, fun goodies to explore. There's videos about how to get started in 3D modeling, how to learn about 3D modeling concepts. There's also all kinds of space science videos. There's different animated science lessons that you can learn about microgravity, about how rockets resupply the ISS. There's all kinds of content there to explore, so I strongly encourage students to go there, to just dive into the site and look at all the resources that we've curated for them.
Thanks, Deanne, and thanks, Future Engineers.
Thank you.
What you guys think?
Dude, that might very well have been the best interview you've ever done.
Franklin, I really appreciate that. Thanks so much.
As good as an Asgardian god.
Thor! That's awesome! R2!
You are great.
Willow!
Blair, 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 Blair,
Hey. What's up?
Come on, man.
An outside look at all things NASA.
We lost a whole day because you were asleep. Next time, just see one film.
One film.
One film.
He does this to us all the time.
All the time. We have to shoot tomorrow morning.
It was good.
9 a.m.? Okay, 9 a.m. All right.
Dude, next time, bring your A game.
Get some sleep.
I thought that
And by
was
the way, you blew it with the Avengers question.
Avengers question. Then it wasn't a dream. It was real!